NASA's daily update on 3I Atlas just dropped, and the one sentence everyone was quietly waiting for still isn't there. There's no mention of behavior stabilizing, no indication that activity is settling into a final, predictable pattern. Instead, buried inside the technical language is a very clear message. This object is not stabilized. And if you've been following this with me, you'll understand why today's numbers might be the clearest sign, yet that this interstellar comet is still in the middle of its story, not the closing chapter. If you don't want to miss what happens next, stay with me to the end. And if this already has your attention, you can subscribe, turn on notifications, or hit like at any time. For the best experience, go full screen and let's walk through what just changed. The day began like any other routine check-in. New images arrived. Fresh brightness measurements were logged. Updated position data came in from ground-based observatories and a couple of spacecraft cameras. Nothing about the schedule hinted that anything unusual was about to appear. This was supposed to be another quiet data point, another confirmation that the object was slowly winding down as expected. On paper, the behavior after perihelion is straightforward. Once a comet passes its closest point to the sun, activity should steadily decline. Less heat means less gas, less dust. The light curve bends downward. Jets weaken. The object starts behaving more like a quiet body coasting along its orbit. That's what we've seen with almost every comet we've ever studied. They flare near the sun, then they calm down. Simple physics. When today's brightness measurements were placed onto that expected curve, the curve failed. Not slightly, completely. Instead of following the predicted decline, the real data sits stubbornly high. Yes, the comet is fainter than it was at peak, but it is still far brighter than it should be at this distance. The downward bend just isn't there. The curve flattens, as if something is actively propping it up. That's the first clear sign that this object is not stabilizing the way models say it should. Something is continuing to feed activity from the inside. If this were just leftover dust slowly dispersing from earlier outbursts, the inner coma would look soft and diffuse, washed out like fog thinning in still air. But when today's deep exposures were stacked, that's not what appeared. The inner coma still shows a sharp central core, and wrapped around it is a fresh, faint arc of material that wasn't present in the stacks for just a few days ago. This arc is essentially a timestamp made of dust, marking a recent pulse of activity. It's close enough to the nucleus that its structure hasn't yet blurred away. That tells us this is not old material drifting outward. This is new, recent activity. Farther out, the tail still has a defined spine. There's a narrow, bright lane running down its center, fed by a focused flow that remains active. It hasn't spread out. It hasn't faded into a diffuse haze the way a dying tail should. On one side, today's images even show a slight thickening, as if a side fan of material has strengthened again, like a system that was supposed to shut down but didn't. This is not the geometry of decay. This is the geometry of a system that's still being updated in real time. Then comes the rotation analysis, and this is where the picture sharpens even more. To track how 3I Atlas is spinning, teams analyze how its brightness rises and falls over hours. As the comet rotates, different surface regions come into view. Some areas are more active or reflective than others, creating a repeating pattern in the light curve. For a stabilized comet, that pattern repeats cleanly. Peaks arrive exactly when expected. The shape of the curve stays the same cycle after cycle. It's predictable, almost boring. Today, when the newest photometry was folded over last week's best fit rotation period, the peaks didn't line up. The main maximum arrived slightly earlier than predicted, and a secondary bump that used to be faint and irregular has grown sharper and more consistent. It now appears at the same phase every rotation, nearly as strong as the primary peak. Like a second heartbeat that has suddenly become steady and loud. To make the data line up again, the rotation period had to be shortened. That means the comet has spun up again. Not dramatically, but measurably. Faster than it was just a week ago. That stronger second peak matters. It tells us that a second active region on the surface has become a permanent contributor. It's no longer an occasional flare. It's locked into the rotation pattern. So the spin isn't settling either. It's still being nudged by forces we can measure, but can't yet fully predict. And then there's the orbit solution, the part that determines whether this is merely interesting or genuinely unsettling. Every new batch of position measurements is run through orbit determination software to calculate where the comet is and where it's going. Gravity does most of the work. The sun's pull, the tiny tugs from planets, all of that is well understood. The complication comes from non-gravitational forces. Jets of gas and dust erupting from the surface act like miniature rocket engines. When material vents, it pushes back on the nucleus. The force is small, but over time it matters. If 3I Atlas were stabilizing, those jets would be fading and the non-gravitational term in the orbit model would shrink toward zero. Eventually, the orbit would be governed almost entirely by gravity. That's not what today's solution shows. The non-gravitational term is still required, and its magnitude hasn't dropped the way it should. Even more telling, its direction has changed again. Using yesterday's parameters, the predicted positions don't match today's observations. The residuals lean systematically in one direction, meaning the push has rotated. To make the model fit reality, the thrust vector has to be tilted again. That combination is crucial. Sustained thrust plus a changing direction is not the signature of a calming system. It's the signature of ongoing internal evolution. So now we have 3 independent lines of evidence, all telling the same story. Brightness that refuses to fade on schedule. Fresh inner coma structure and a tail that remains sharply defined. An orbit that still demands a changing self-generated push. Add to that a rotation period that keeps drifting and a second active region that's now locked in, and you have a very clear picture. This object is not stabilized. When you step back, it actually makes sense. The passage near the sun didn't just heat the surface and move on. It initiated a slow thermal wave that's still migrating inward. Heat moves gradually through ice and rock. Deeper layers are only now reaching temperatures that trigger sublimation. Inside this nucleus are pockets of volatile ice buried along ancient fracture planes, each at a different depth, each with its own threshold. As the heat reaches them, one after another turns on. Each activation does 3 things. It injects fresh gas and dust into the coma, keeping the brightness higher than expected and carving new shells we can see. It adds torque, twisting the spin and altering the light curve. And it changes the direction and strength of the outgassing force, forcing orbit models to be updated again. From the outside, it looks like an object that keeps fighting the models. From the inside, it's a stressed nucleus trying to redistribute energy and pressure under conditions it hasn't experienced in billions of years. This doesn't mean breakup has started. There is no confirmed fragmentation, no clean trail of debris, no catastrophic brightening that screams imminent failure. The nucleus is still intact, but also means we can't treat this as a quiet outbound comet anymore. A stabilized object gives you predictability. This one does not. Its rotation keeps creeping. Its activity pulses. Its brightness refuses to obey the simple distance relationship. Its orbit still needs a changing push term. From here, there are only 2 plausible paths. One is stabilization. The deeper volatile layers finish venting. Heat dissipates. The spin-up slows and locks in. Activity fades. The comet leaves the solar system altered but intact. The other path is continued stress. More late pulses, more torque, more internal adjustment until the structure can't keep up. At some unknown point, cracks propagate, pressure escapes uncontrollably, and the nucleus fails. Right now, we don't know which path this object will take. What today's update makes clear is that we are not at the quiet end of the story. We're still in the middle. The interior is still reacting. The spin is still changing. The orbit still demands correction. The coma still shows fresh structure. Every one of those facts says the same thing. This object is still evolving. 3I Atlas formed around another star, survived billions of years in interstellar space, and then plunged into an environment unlike anything it had known. Now, as it moves outward, it refuses to calm down on schedule. Every day, without stabilization, brings us closer to learning what happens when an interstellar visitor is pushed to its limits. The teams watching this object are checking it daily, sometimes multiple times a day. They're watching for the moment when the data finally bends towards stability, or for the moment when it doesn't. If you want to see which way this goes, stay tuned. This story isn't over. Not even close. And in astronomy, when something refuses to behave, that's usually when we learn the most.